Good evening and welcome everybody to the Royal Society of Edinburgh. Some of you will be familiar with these lecture evenings and some not, so I'm going to say a word of introduction, particularly, first of all, a welcome to our guest speaker this evening, Professor Dame Jocelyn Bell Burnell. This is the second time she's addressed us in the last period of months, and I look forward to this completely different topic this evening. The topic is going to be a celebration of women in astronomy over 100 years. So we look forward to that. We can have nobody better qualified than our speaker this evening, who studied, first of all, in Glasgow University and then finished her PhD in Cambridge. She was made a dame in 2007. She's a Fellow of the Royal Society and a Fellow of the Royal Society of Edinburgh. And she's also a foreign member of the US National Academy, which is a rare appointment, a rare honour. Just for those of you who are not familiar with the Royal Society lectures, and this one in particular is actually one of what we call the Edinburgh Lecture series. And the Edinburgh Lecture series started in 1992, which is quite a long time ago now. It was sponsored by the City Council and remains to be sponsored by the City Council, and all the universities and colleges of Edinburgh take part in that sponsorship, including the FRSE. And this is the first of this year's series of Edinburgh Lectures. There is available to you a list of these lectures which finish in the summer with a lecture by the Dalai Lama. And the theme of this lecture series is extraordinary feats. And that is what our speaker this evening is going to be talking about. So without further ado, could I introduce Dame Jocelyn Bell Burnell. Thank you.
Thank you very much for all of you for turning out on a February night. There have been worse February nights, but it is nonetheless a February night. So thank you for being here. And thank you to the Royal Society of Edinburgh for the opportunity to take part in this lecture series. I am a professional astronomer, and one of my interests has been the position of women in astronomy, in science, in engineering, and so on. And so what I'd like to talk about tonight is some exceptional women astronomers: Caroline Herschel, Cecilia Payne Diposkan, Vera Rubin, and Rebecca Elson. And then in perhaps the last third of my time, talk a little bit more generally about women in astronomy and women in science, engineering, and so on. So I start with stories about 4 women, 4 really unusual and exceptional women. And the first of them is Caroline Herschel. She was born in Germany. Her father was a military musician. Her mother was a hausfrau who could neither read nor write and didn't really understand why women needed to read or write. Because she was a girl, she was denied much of an education. She had had chickenpox or smallpox as a girl. She had a face that was really rather pockmarked, and her father advised her that since she was neither rich nor beautiful, her role in life would be as housekeeper to one of her many brothers. And she became, in due course, housekeeper to a brother in Germany. She asked him if she could learn French. He said no. She asked him if she could go to dressmaking classes, and he said yes, provided everything she made was for him. There was an older brother, William, that some of you may have heard of, who was also a musician and had come to Britain, to Bath in particular. he asked his brother if Caroline could be released to come to England to be housekeeper for him. And this brother agreed, provided William paid the cost of a servant to take Caroline's place. So as a young woman, she came to Bath. She didn't awfully like the social milieu in Bath, but that's another story. When she came, she had to learn English. She also had to learn bookkeeping to keep the household accounts. And she had a rather nice soprano voice, so she trained also to sing. And when William was conducting, she would sing as a soloist. William's interests then turned away from music towards astronomy. And Caroline's diary is full of despairing comments. They lived in this little house in Bath, and she said every room in the house was full of mirror-making activities, and his lace cravats were getting spattered with pitch, and so on. But William actually was a very good maker of mirrors. He made lots of them. He didn't always understand why some were good and some weren't, but he made so many that he could pick out the good ones and work with them. And in the back garden of this house, with one of his homemade telescopes, he discovered the planet Uranus. There's now a plaque in the back garden recording this, that he lived there and that he discovered Uranus there. And Caroline lived with him, of course, and increasingly helped him with his astronomical observations. She also on occasion helped out when he was grinding mirrors, like on the occasion when he had to work for 16 hours non-stop, so she fed him food, forkful by forkful, as he continued polishing the mirror. After the discovery of Uranus, the king, George III, offered William Herschel, a position as astronomer to the court. They didn't quite have astronomer royal at that stage, but building up to it, on condition that the Herschels moved to be rather closer to Windsor than was Bath. So they actually moved to Slough. And he built a very big telescope there, and he and Caroline regularly used that telescope at night. You know, one of the problems when you go out into the dark is it takes your eyes a few minutes to adapt to the dark. Maybe, well, more than a few, 10 or 15 minutes. The problem for an astronomer is you want to have your eyes adapted to the dark, but you also want to write down what you're observing, for which you need light. And the way the Herschels organised it was he would be up on the telescope structure observing, and she'd be sitting nearby at a little desk with a very low light, recording. And he would call out each star, and she would note the time and write it down. She was a very slight woman, very frail, you'd think, but somehow she managed to work at night, often through wintry nights. She once complained when the Thames lapped into their garden. On another occasion complained when the ink froze. But mostly she persevered. And having observed all night with William, then over breakfast she quizzed him, and that way taught herself geometry and calculus. This is a woman with no education. Then she'd be writing up the night's observations for publication, managing the household, giving the servants instructions about what to do, and maybe getting a little bit of sleep before starting all over again. Tough little lady. When William was away, as increasingly he was, she used a telescope that she'd given him to sweep the skies to look for comets. And she found 8 comets altogether. An image here of a couple of recent comets. They are very, very beautiful things. I suspect the ones she spotted were a good deal fainter than those. Those ones kind of shout at you. But she found 8 comets. She was very modest, and whenever anybody praised her, she reflected the praise back to William. And I think what was going on was the only way she could be a scientist and be a woman acceptable in the eyes of society at that time was to pretend that it was all William, that she was merely doing what he told her. In fact, it's absolutely clear that she knew what was what. While they were at Slough, if the royal family was at Windsor and had some guests that they didn't know what to do with, they'd pile into a carriage and go round to the Herschel's place to be shown the telescopes. If William was away, Caroline did the honours. And it apparently absolutely clear to everybody, she knew one end of a telescope from another. She knew exactly what was going on. She was not stupid. And she also knew the night sky very, very well in order to pick up comets. I wondered if you noticed on the first slide the last few lines. William died. She moved back to Germany. She still hadn't been recognised. But when she was 78, the Royal Astronomical Society in London gave her a gold medal. When she was 87, the Royal Irish Academy in Dublin gave her membership. And the King of Prussia gave her a gold medal when she was 96. It's just as well she lived a long time. She's now being recognised more for her contribution, and she's being written back into history, into the history of astronomy, which is good to see. I'm very pleased about it. The next woman I want to talk about is born much more recently. She was born Cecilia Payne, and she married Sergei Diposkan, so to astronomers she's known as CPG, or Cecilia Payne Diposkan. Her father had been an Oxford Don at the time when, if they wanted to marry, they had to resign their fellowships. So he had resigned his fellowship and the family had moved to Wendover, got married, and she was born shortly afterwards. Her father was aged 56 at the time. She had an aunt who was a botanist, and she was quite keen on doing botany herself. I find this quite interesting because it's always been acceptable for women to do nature study. And I think botany is sometimes perceived as a jumped up version of nature study. So it's okay for women. But other subjects might not be. But anyway, she was keen to do botany. At one point in her career, she was at St. Paul's Girls' School in London. And her music teacher was keen that she become a professional violinist. Her music teacher was one Gustav Holst. So she must have been good to get that kind of recommendation from somebody of that calibre. But she was determined to be a scientist, and she really had to fight to get a science education at school. She got sufficient education to get a place at Newnham College, where she was reading botany. And that was going okay until one day in 1919 when she recorded the following. And this is of interest to any astronomers in the audience. She did some physics. She has interesting stories about being lectured by Rutherford and Bohr and people like that, but mostly she was on the biological sciences side. And there had been an expedition by one Arthur Stanley Eddington to, two parts of the expedition, one to Brazil and one to the island of Principe off the west coast of Africa, immediately after the First World War end, to observe a total eclipse of the sun. During the First World War, Einstein had published his theory of relativity. Eddington, as a conscientious objector, was still at work in Cambridge and received some of Einstein's manuscripts and realised how important this work was, and realised that there was a total eclipse of the sun in 1919, which could be used to test out Einstein's theories. So in anticipation of the war ending in time, he started organising this expedition. And the war did end in time, and it was a bit of a scramble, but they got there. And he was due to give a lecture in Cambridge about that expedition. This is what Cecilia Payne writes in her autobiography. There was to be a lecture in the Great Hall of Trinity College. Professor Eddington was to announce the results of the eclipse expedition that he'd led to Brazil in 1918. 4 tickets for the lectures had been assigned to students at Newnham College, and almost by accident, for one of my friends was unable to go, a ticket fell to me. The Great Hall was crowded. The speaker was a slender, dark young man with a trick of looking away from his audience and a manner of complete detachment. He gave an outline of the theory of relativity in popular language, as none could do better than he. He described the Lorentz-Fitzgerald contraction, the Michelson-Morley experiment, and its consequences. He led up to the shift of the stellar images near the Sun, as predicted by Einstein, and described his verification of the prediction. The result was a complete transformation of my world picture. I knew again the thunderclap that had come from the realization that all motion is relative. When I returned to my room, I found I could write the lecture down word for word, as I was to do for another lecture a couple of years later. For 3 nights, I think, I did not sleep. My world had been so shaken that I experienced something very like a nervous breakdown. The upshot was perhaps a foregone conclusion. I was done with biology, dedicated to the physical science forever. The next day, I confronted the college authorities with the statement that I was going to change my shop and read physics. Cambridge University regulations never were very flexible, so she had some trouble negotiating this change, but she did a lot of physics and astronomy and actually got to know Eddington quite well. She thought she'd like to do a PhD in astronomy and consulted Eddington. And he said, don't stay in England, go to the United States. So as a new young woman graduate, she headed off to Harvard, well actually Radcliffe College, and to do a PhD. While she was there, she was put to work on looking at the spectrum of the Sun. And she discovered it was nearly all hydrogen. Well, that's obviously rubbish. The Earth is not nearly all hydrogen, so the Sun can't be, can it? Must be wrong. She published her results saying, this is what I found, but it's almost certainly wrong. The director of the observatory, whom I won't name, repeated the observations a few years later, came to the same conclusion, and published the result without acknowledging her. She got her PhD and she stayed on. She was paid out of the equipment grant for most of her working life, and only towards the end of her life, when she became chair of department, they sort of had to recognise her existence, and she became a person and she got a salary. She was the first PhD in astronomy and the first female PhD at Harvard, Radcliffe. She lived right on into her 80s, and she was at the forefront of astronomy, particularly spectroscopy as applied to astronomy, all the way through that lifetime. New branches of astronomy opened up, ultraviolet, infrared. She was right in there as an 80-year-old. Right at the forefront of this new stuff, totally unfazed by all the changes that were happening ever more rapidly. She saw through a lot of changes, understanding of quantum mechanics and things, and through her astronomical observations, she was supplying data to help confirm and push forward those theories in physics. She really was a most remarkable woman. I now have to teach you a little bit of astronomy, and apologies to those of you who know this, but in order to understand the context for the next couple of women, it's important, I think, that I do this. I have here a lovely image of a galaxy. This is a bit what our Milky Way would look like if we could get outside it. But of course we're embedded in it, so we don't have this kind of bird's eye view. There's a hub of stars in the centre. I should use my pointer. Hub of stars in the centre. And spiral arms. Some lanes of dust and some lanes of stars. Lanes of dust, lanes of stars, and so on. And the whole thing is rotating like a Catherine wheel. It's going round like this. And like a Catherine wheel, it's flat and round. We're seeing it face on here, but if you saw it edge on, you'd see it would be quite thin. It's a disk. Incidentally, if this were our galaxy, our position, the sun's position, would be somewhere like this, about 2/3 of the way out from the centre, in the suburbs, in a spiral arm. We're not the centre of anything. Now, you can measure the rotation, how fast these galaxies are spinning. And you can also make an estimate of how much mass, how much matter there is in the galaxy. You can sort of do a count up the stars and guesstimate their weight and work out how much gravity there is. And it turns out that these things are spinning so fast, they ought to fly apart. They ought to centrifuge apart. But that one isn't. Nor can we find any example of a galaxy flying apart. And we have pictures now of millions of galaxies. We have pictures of galaxies merging, but none flying apart. So how can that be? And with that introduction, I'll move on to our next female astronomer, one who is still with us, although she is not young. I would guess she's pushing 90 by now, certainly 85. She lives in the United States. She wanted to be an astronomer, scientist from quite an early age. She recalls applying to Princeton University for a place to study for a graduate degree and being told by Princeton they didn't take women, so they weren't even going to send her a brochure. She's not had it straightforward, shall we say. One graph. This is another way of looking at the galaxy that we were just looking at. Along here is distance out from the centre, and up vertically is how fast it's spinning. And you see it's going up to speeds of about 250 kilometers every second. It's spinning really fast. Once you get out towards the edge of the galaxy, so that most of the mass of the galaxy is behind you, then the further out you go, the speeds should drop. The velocities should drop. They should drop following this dotted line. But what we find is the line keeps up. The velocities don't drop. And they 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 don't drop. So again, a question, what's going on? Why doesn't the galaxy fly apart? And why don't those speeds drop? It was Vera Rubin who first found the way these speeds keep up. And to begin with, she was not believed. If a man had done it, I think he would have been believed, but she wasn't. But she was the first to identify this, and finally convinced her astronomical colleagues that there was something going on here that needed attention. What has turned out to be the case is you need some extra gravity. You need extra gravity to stop the galaxy flying apart, and you need extra gravity to allow this line to keep up high, the way I was showing you. But this extra gravity can't come from something visible, otherwise we'd see it, and we would have included it in our sums. It must come from something that doesn't shine, something that has gravity, but no luminosity. And with great originality, astronomers have christened this stuff dark matter. Matter because it's got gravity, and dark because you don't see it. So we can see many, many galaxies, very, very pretty, none of them flying apart. Presumably they all are embedded in a ball of dark matter, a halo of dark matter. Dark matter also shows itself in one or two other places, and in particular in clusters of galaxies. I've shown you pictures of galaxies which are great conglomerations of stars, probably about 100,000 million stars in each of those galaxies. The galaxies themselves quite often are grouped. And again, with great originality, we call these clusters of galaxies. And our galaxy, along with the Andromeda galaxy, is part of a cluster which, surprise, surprise, we call the local cluster. And there are other clusters. Our local cluster is not very rich, but there are other ones that have many, many more galaxies. So this photograph shows some galaxies in the constellation of Perseus, and almost everything in this image is a galaxy. And these galaxies are milling around, you know, like people in a crowded room. They're sort of battering around. But if you work out how fast they're moving and how much gravity there would be from all these galaxies, you find that they're moving so fast they should escape from the cluster. The crowded room should empty, if you like. And it's not. So there must be something that we don't see that's providing more gravity. Oh, yeah, it's probably that dark matter. So not only is each galaxy got a halo of dark stuff that doesn't shine throughout the cluster, holding the cluster together, there must also be dark matter. Each of these orange blobs is a galaxy in a cluster. You can perhaps also see some blue streaks, because way behind this cluster, somewhere way, way back there, there is an object that's giving out blue light. Distant galaxy, distant quasar. But it's bluer in colour than these foreground galaxies, if you like. And as the light from that distant object, and I hope you can see the jug of water, cluster of galaxies, you're the observers with telescopes on Earth, and a ray of light coming this way is bent by the gravity of the cluster and focused back round. You believe that light comes in straight lines, so you think the light has come from way back here. And similarly in other dimensions, and you think there's a ring, or maybe an incomplete ring of light, because of the focusing of the mass of that cluster of galaxies. Each of these blue arcs is one of the images of that very, very distant galaxy or quasar. And we can tell by the size of the arc how much mass there is in here and how much dark matter. And dark matter makes up a sizable amount of our universe. There is as much dark matter, well, there's a lot more dark matter than there is us matter. There's maybe 6 or 7 times more dark matter than there is the kind of matter that we're familiar with in our lives. The final woman I want to talk about is called Rebecca Elson. And she's a good deal younger, or would be a good deal younger, than any of the others I've spoken about. But sadly she died of cancer at about age 40. She was born in Canada. She did some of her studies in Princeton, some of her studies in Canada, and she worked for quite a while in Cambridge, UK. For some of her graduate courses, she was one of very, very few women in the class, and she did not enjoy it. She said it felt like walking into the men's bathroom by mistake. I have included her because she's one of the few astronomers I know who has written poetry. And I have an interest in poetry about astronomy and space. And I can only think of two astronomers who write poetry. And Rebecca Elson's is particularly good, I think. So I want to read you a poem she's written about this dark matter, about trying to find dark matter, to understand what it is and just how much of it there is. Remember that it's the stuff that adds gravity and holds things together. It's called Let There Always Be Light, Searching for Dark Matter. For this we go out dark nights, searching for the dimmest stars, for signs of unseen things to weigh us down, to stop the universe from rushing on and on into its own beyond, till it exhausts itself and lies down cold, its last star going out. Whatever they turn out to be, let there be swarms of them, enough for immortality, always a star where we can warm ourselves. Let there be enough to bring it back from its own edges, to bring us all so close that we ignite the bright spark of resurrection. And sadly, since she's written that, we have learnt that there is not enough dark matter in the universe to prevent the universe from rushing on, expanding forever and ever, and the stars going out. The universe looks a lot bleaker. The outlook looks a lot bleaker. So, leaving the stories of these four exceptional women, I want to say a little bit about women in astronomy today and women in science and engineering today. The astronomical community worldwide has an umbrella organisation called the International Astronomical Union. And people belong to the Astronomical Union. And because the wife of the General Secretary at one point was being very badly treated, he decided to start compiling statistics on, well, statistics disaggregated by gender for the membership of the International Astronomical Union. And so the International Astronomical Union now has data going back probably a decade, maybe more, showing the number of women, the number of men. And I've taken a look at that data and got a subset of it here. For those in the audience with a concern for statistics, I have focused on countries that have more than 100 members, so that we're not too troubled by small number statistics. And I have listed them by the fraction of their delegation, the percentage of each country's delegation that is female. So it runs from Argentina, which has 30% of its astronomical community female, through Ukraine, Italy, France, Brazil, Spain, Mexico, Russia, Greece, China, Australia, Belgium, Poland, Sweden, Canada, USA, UK, 12%, Netherlands, South Korea, Japan, 6%. Japan 6 is probably not a surprise to anybody. It's changing, it's growing, as are most countries. But terrific range in this table, from 37% to 6%. The average for the whole world is 15%. And the English-speaking countries, Australia, at the world average, Canada below, USA below, UK below. The northern European countries like Netherlands and Germany are low. The southern European countries, Italy, France and Spain, are high. Not what I would have guessed. There's probably a lot going on here. This column you can safely ignore. It was me just attempting to give an idea of how accurate these percentages were. I get a number of messages from this. First of all, in some countries, there are lots of female astronomers. Being a female astronomer is not peculiar. In other countries, there are fewer. This must be for cultural reasons. It's nothing to do with women's brains. And I think I still have to say that, because every so often somebody will pop up and say, oh, women can't do science. The United States makes up about 1/4 of the whole membership, and yet it's below the average, which is quite a strong message. There are a few caveats which I need to present to you. To be a member, you have to be a tenured astronomer, and you have to be nominated by your country's astronomical society. And for both those reasons, the numbers of women will be on the low side. There are many more young women in astronomy than senior women. And to be nominated by your country's astronomical society, this probably means nominated by the white male establishment in your country. And without, I think, deliberately intending it, the white male establishment tends to identify more white males to succeed them, and the women may get overlooked. There's the web address for the data if you're interested in exploring it further. And apart from saying that I know there are similar, not identical, but similar distributions for physics and for maths, I think the only other thing to say is there's probably a PhD in this, sorting out why some countries are high and some countries low. I don't think there's any one answer. Women in science, engineering, technology today, the numbers are growing. The percentage is improving, but slowly. The largest increases have tended to be at the student level. They're taking much, much longer to percolate through to the senior levels. We know that there are issues around work-life balance and also issues around balancing a family and a career that need to be addressed. But that's not the whole story. Don't just blame it on women having children. There are also issues to do with the climate in the workplace, the atmosphere, the ambience. You can think of women as being like the canaries in coal mines. Remember, miners used to take canaries down, and if the canary keeled over, they knew the air was bad and they ought to get out. Canaries being more sensitive. You can think of women as being an indicator that maybe things aren't all quite as they should be in a department or a group if they're leaving or not succeeding. The shortage of women in senior positions, probably due to quite a few factors. Clearly in this country, too few entering, too few school kids doing science. Too many leaving, the pipeline leaks, and the ones that remain often don't get promoted as fast as their male colleagues. Of course, that's because they're not good scientists, isn't it? Or is it? And I think all of these are true. There have been programs to help women. It's noted, for example, that women are more cautious about applying for things. When they do apply for grants, they apply for smaller amounts of money and shorter periods of time and so on. So there have been programs to make women more assertive, braver. That has the assumption that there's something wrong with women, that the male norm is normal and it's women who are deviant. I don't actually agree with that, and I think it's one of the things we're coming to recognise, that just because women aren't so successful at playing the male game, it might be the male game that's wrong rather than the women, or both. So I feel that science should be moving towards women as well as women moving towards the science, women changing as well. Long term, I think the climate of science has to change. Or in some famous American words, rather than fix the women, fix the system. And I suppose it's not surprising, because science in this country has been male-dominated forever. It's been named by men, developed by men, interpreted by men, and it's inevitably bound to become what most men are comfortable with. Operates to male norms, male ethos. If that's true, then what we are seeing as science and calling science is actually possibly not science as she really is, but science as interpreted by the men who have done it. And if I'm right that science has that slight male tinge to it, then that white male tinge to it, people from other backgrounds may be slightly uncomfortable in it, because it's just not quite where they are. In the United States of America, the National Science Foundation used to fund programs to support women, and it has stopped because it wasn't getting anywhere. And it has decided instead to offer funding to universities, the central administration of a university, to change the culture in the university. Institutional change. Ireland has followed suit, but I'm not sure in how big a way. And the kind of thing that universities that have had this NSF funding are doing are they're alerting men and women to things like unconscious bias. We all think men are more authoritative than women. Not just men, women do as well. And there's this kind of bias that we have. And also to raise questions about the structure of science in that university and identify institutional sexism. In the UK, there have been many, many initiatives to improve the position of women in science. And the sheer number of these initiatives speaks volumes about the concern. These initiatives have often been led, carried out by women, usually working in their spare time, because it doesn't count as part of your normal working load and it doesn't help you do more research. And there have often been local initiatives appropriate for what's happening in their place, but different from what's happening 30 miles away, and probably unaware of what's happening 30 miles away. One of the initiatives in academia, however, has grown legs and started walking, and it's called Athena Swan. It's a program of accreditation of universities and university departments, accrediting those that demonstrate themselves to be women-friendly and endeavouring to have a climate in which women are comfortable as well as men. And one of the things I'm currently doing for the Royal Society of Edinburgh is working on a report on women in science, technology, engineering, mathematics in Scotland. And it is our intention to very strongly commend, if not even require, the Athena Swan accreditation of universities before they get research funding, which will put some cats amongst pigeons, except that the medical officer from the Department of Health, Dame Sally Davis, has already indicated that medical sciences departments will not get funding unless they hold Athena Swan accreditation. So it's already happening. There are other similar things around, like the Institute of Physics, Project Juno. So there is considerable movement at the moment, and it's going to be worth watching this space over the near future. One of the other things that the group working on this report for FRSE is concerned about is that we move from a phase of lots of very good but local ad hoc initiatives to having a proper strategy. By being better connected, we be a stronger force and can perhaps better bring about change. Meanwhile, until Nirvana arrives, Improving the management of departments and research groups would be a big help. Educating and sensitizing men and women about gender differences, because there are differences, and about unconscious prejudices would be a great help. For girls, having role models, mentoring, networking, possibly girl-only classes. I've heard of one or two schools in Scotland that were thinking about that. I don't know if they've ever done it for science subjects and what the effect was. And I also personally believe that single-sex schools and colleges let girls experience, and indeed practice, female leadership, which takes them a long way. It seems that good management benefits everybody, but benefits women more. Bad management affects everybody, but affects women more. And incidentally, it also seems that poor physics teaching affects girls more than boys. For the women, well, I think we laugh, indeed. There's not an awful lot else we can do. But it costs being a female in science, being a female working in science academia or working in science industry. All of us probably have a number of slightly horrific stories about what people have said to us or done to us. Cherish those stories. They make superb after-dinner speeches. And stories are very, very powerful, something that we don't always recognise. For all of us, improve the management. One of the best chemistry departments in the country has a youngish man as head of department, and sometimes he has to leave at 3 o'clock to get the kids from school. It sends out a superb message, a brilliant message. And don't expect women to be we men or she males. And as a last word, thank you very much for your interest.
Well, I'm getting to know Jocelyn quite well now. That was a typical Jocelyn Bell Burnell presentation. Very vigorous, very entertaining, full of interesting stuff, and at the end a pretty powerful message about the opportunities, the role and the development of science so that women can take a full and equal part. And now it's your turn to take a full and equal part by asking her some questions. So please raise your hand. A microphone will come. Please keep your questions short. We don't need 10-minute examination answers for the questions. So who would like to ask the first question? Son of Silence. Yes.
Thank you very much for a wonderful talk. I'd like to ask if you think to carry on about the discrimination of women, if now that so many universities and institutions give the top jobs to people who bring research money in, are women disadvantaged because of that?
I think, is it okay if I keep sitting? Can you? Yeah, okay. I think women who have caring responsibilities are probably going to lose out. Because caring responsibilities take you away from the research activity. That, of course, is not the whole of your life. Hopefully not, anyway. It was Dame Kathleen Ollerenshaw who said, first you raise your children, then you nurse your parents and your parents-in-law through their terminal illnesses. Then, because your husband will probably die before you, you nurse him through his terminal illness, and then you're free to do your own work. It's not usually that bad, but and increasingly caring responsibilities are shared, which I think is the way we have to go. Until that, there is a risk that the people who bring in the biggest research money are the men. Yes.
Next question. Yes, on the front, very front.
thinking about admissions to university science departments, which I've had something to do with in the past. If we had equal numbers of young men and young women applying, you could say it was all my fault, what the outcome is. But we don't have equal numbers of young men and young women applying. So we've lost the game before we start. Do you have any thoughts on this?
Yeah.
That's a physicist speaking. Biology undergraduate classes are predominantly female. Medicine undergraduate classes are now predominantly female. It does enormously change from subject to subject within the sciences and engineering what proportion of undergraduates are female. The sad thing to note is even in the areas where the undergraduates are predominantly female, the professors are predominantly male. And it's not just a case of waiting for those young women to get up to professorial level. They don't get there.
And these data you will see when the STEM report, this Science, Technology, Engineering and Mathematics report, which Jocelyn is working on along with others in the Royal Society, which will be published, we hope, in April, clearly illustrate. And we have had meetings here before about why do we have this phenomenon of the almost equality in some disciplines at the point of graduation, and an enormous inequality when it gets to seniority. There are some explanations of that, but what we have to see is that changing. Jocelyn, how long do you think it's going to take?
It is getting better because we're getting much more aware of the issues, and I think we're getting better at identifying what are the key issues. I could be proved wrong on that, but yeah, it's coming. I'm hopeful that the kind of younger man who's now becoming head of a university department or head of a research group, A, has a wife who wants a career, B, helps take care of the children, and C, is alert to a number of these issues. I think it could change quite fast.
Question at the back.
You alluded to the fact that not a great deal has changed over too many years. Is that because women are too polite? Do we need, and if there were any other group in society that was represented 50% of society, that was so systematically discriminated against, wouldn't we have a minor revolution? How about tying oneself to the Queen's racehorse?
Or Lysistrata, yeah. Yes.
This is a low-key Jeffrey intervention.
Yeah. I have found it very difficult during my life to know which times to protest, because you can over-protest, and that's just Jocelyn banging on again and nobody listens. So finding the right balance between politeness and protest is quite tricky. I would have been helped if there had been other women. I've been exceptionally lonely in my career. It would have helped if there had been other women, that I could have said, did I overdo it in that committee this afternoon, or was I too quiet? And once you get a number of women who think alike on a committee, kind of pincer movement.
And there's a question right at the back. Oh, sorry, one at the front first.
It is very polite of me to take the microphone. Perhaps my point isn't going to be polite, and I wonder if our marvellous speaker will forgive me if it's not. One observation, I wonder why our speaker is surprised at the figures for, I think it was Spanish, French, Italian women. We mustn't be prejudiced ourselves. Many women in those societies, matriarchal perhaps, are pretty tough, pretty vigorous, and pretty revolutionary. That's the observation. And really, just a point about telling stories. It does help, too, if we tell stories about men who have behaved well. Very often our fathers, our brothers, our uncles, our heads of department, the colleagues with whom we work. There are times when women actually can demonstrate a great deal of power and authority by being chivalrous and giving the floor to the man. The head of department who claimed to have done the research, which actually the woman astronomer had done herself. I wonder what happened in the end with that story. I would have liked to have known more. In the end, was the credit shared? What happened to that man? So, yes, laugh, but let's tell the good stories too.
Okay, thank you.
At the back.
Hi.
It is on.
In 1991, there was a radio program, I think it was 1991, and about the discovery of pulsars, and I taped it. That's it there. So I listened to it the other day, and you were in it mainly. I like your sense of humour, because you were saying that when the press discovered that you were a female and had discovered pulsars, they wanted to know your vital statistics, which you conveniently forgot. Then they wanted to know, were you bigger or smaller than Princess Margaret? So it pays to have a sense of humour sometimes, I think. Thank you.
And remember the stories to tell again.
Yes, a question here on the right.
President, can I just say, and you had a wonderful example tonight of just what a remarkable lady Jocelyn is. I first met her at Gatwick Airport, I think about 1980. She was moving north
for an interview
to set up. I came up here at the end of the 1970s to set up a funny thing called the Open University. I met Jocelyn, I think, at Gatwick Airport about 1980, and I have to say, and I don't want to embarrass her, President, but she is, or was, for me, and for all the students doing physics courses, probably one of the best tutors we had in the whole of Scotland. And you've seen a wonderful example of it tonight. Could I just mention, President, that my own wife was denied doing geology as a degree at Sheffield by the chap who was the Sorby professor. She then did a degree in geography, went back to the professor of geology and said, I'll now do a degree in geology. He couldn't stop her. She then, my wife, became his first research student. So it's an incredible story, and Jocelyn has demonstrated so clearly tonight what a remarkable lady she is. Thank you, President.
Jocelyn, could I take you back to the first part of your talk about the four remarkable women scientists and the way in which they came into astronomy was really, truly remarkable. Your first example from somebody who had no virtually no education at all. Can you just tease out? I mean, that's presumably to do with the inherent determination of the person and the qualities of the person. But these women, at least that particular woman, wasn't afforded really any opportunity. How did she actually break through? Did she really break through at the end of the game? I mean, you told the story that she was actually pretending that she was reporting her brother's work.
Yeah.
It's the only way that she could be taken seriously. It'd be interesting to tease that out of you.
I think she did break through, but I think if you had said to her what did she want to do, she probably wouldn't have known or been able to articulate an answer. She recorded in her diary when William's interests shifted from music to astronomy, oh, so it appears I've to become an astronomer's assistant. But she went at it fully, thoroughly, with energy. And I think that's probably how she broke through. We don't all have control of our circumstances, but making a realistic assessment of where we are, what can change, what cannot change, and going for the things that we can do, I think is often a very good recipe.
And was the recognition of these four women, was it slow to develop? Did they, for instance, the discovery of dark matter must be one of the most fundamental discoveries of the study of the universe.
Yeah.
I mean, was this recognised quickly, or did that particular person suffer from from being a woman in terms of what she was doing?
I think Vera Rubin did suffer in that she had the data on the way galaxies rotate, which was a very strong pointer, and people kept saying, no, there must be something wrong with your measurements. And Cecilia Payne Diposkan simply wasn't believed when she said the sun is full of hydrogen. Right. So, yeah, they had it pretty tough.
Yeah. Now, questions? Any further questions from the audience? Yes, down the front.
Just a matter of clarification. I was absolutely thrilled in reading the story of Herschel, how he came to Britain and how he built these grand telescopes. And I forget now whether it's his niece or his younger sister who took all the notes down.
It was his sister Caroline.
Yeah, I thought so. Now, in the book I read, published a year or two ago, it made it clear that it was accepted by him and gradually by everybody that it was she who found Uranus.
I hadn't heard that one. But
really?
She found comets, certainly.
Yeah.
Yes.
More an observation as opposed to a question. But you were saying that girls in science, or ladies in science, aren't doing as well. But I've been reading for the last 15, 20 years that girls at school seem to be outstripping boys in both mathematics and science, which seems a contradiction in what you're finding.
Yeah.
And then your other observation where you were saying it may be better going back to single-sex schools, would that not be a disadvantage? Because then you're going to come out later in life and have this clash again.
Right. I'll answer particularly the second half of your observation, which is a very important one. In the United States, there are a number of prestigious women's colleges, places like Smith and Mount Holyoke. And somebody did a survey of how successful in later life were the women from these prestigious women's colleges compared with women who'd been at prestigious co-ed places like Harvard and Princeton and Yale. And using things like how many of the women got doctorates and how many were subsequently featured in what we'd call Who's Who, but the equivalent in America, it turned out that the women from the co-ed colleges were less successful than the women from the single-sex colleges. So it looks as if being at a single-sex college from the point of view of women up to the point where you get your bachelor's degree actually pays off. Of course, we also know that it's better for men to be in co-ed. So you can't win both of those.
No. There's a question right in the middle there.
Following on from that, do you know if there's been any recent change in the results of girls in particular in Oxford and Cambridge, where what used to be prestigious colleges like Somerville were just for women?
Yes.
Now we've got men there as well. Mm-hmm. And I had to write to the college at one point and say, look, we've got good women who've done things, and here's your little publicity blurb with all these pictures of men on it. Why? And no scientists on their little blurb. They did apologise to me afterwards.
Yes, in Cambridge there are still some women's colleges. In Oxford, the last women's college went co-ed 4 or 5 years ago. And what a number of us have noticed is that positions like that of President of the Junior Common Room have all been male ever since. It's a very funny world.
Yes? Alice.
Jocelyn,
wait for the microphone.
Recognising a lot of things that you've said already. Thank you. Thanks very much. Recognising a lot of things that you've said already, and one of the main criteria you said is to have a sense of humour in a sense. What advice would you give to young women graduates in STEM now embarking on their careers so that we don't see the 73% attrition rate from STEM subjects?
Yeah. Yeah, so of female graduates in science, technology, engineering, mathematics in Scotland, only 27% stay working in those sectors. It's a huge wastage, and a lot larger than the wastage of men. I would hope young women would feel encouraged to go into science and engineering and so on. They should take care to keep a network, keep contact with the other women that they studied with, because they may be rather more isolated to begin with in their jobs. But I do believe it will get better, and I think it's probably going to get better quite fast. I find it an immensely rewarding kind of area to work in. So if you have the abilities and you are interested, for God's sake, go for it, would be my message.
Yes.
Could I just say, you've just touched on something that I think is now very important, networking and mentoring.
Mm-hmm.
Having been the only woman in the department, etc., for God knows how long, and never having had another woman to talk to in the department, I know how important this can be.
Yes.
But it's now, I'm a chemist, and the Royal Society of Chemistry is pushing this, networking and mentoring.
Yes.
So long as the mentor is a woman, I think it's important, a woman who knows the problems. And I speak as one who was, I was an undergrad in Glasgow, I know that physics department well, but I was at a women's college in London for a number of years. It's the only reason I ever had a career, because I got the job because I was a woman. It's long past for me, but I do think that's the really important thing for the future. There will be more women coming through, and you do need that networking thing, which I certainly never had.
Yeah. There is an argument for having a male mentor, a sympathetic male mentor, because that helps men see the world through women's eyes.
Don't you think women have to manage better in a co-ed world? Just saying single sex for women because they can't cope in a co-ed world doesn't seem to me to fit people for later life.
Okay, but the evidence I have from the United States is that it does. That if you stay single sex till the end of your bachelor's degree, for women, it actually means you're more successful. Now, maybe somebody needs to do that study over here. That is a US one.
Could I just ask one more question, Jocelyn? At the very beginning, you showed the league table for the different countries.
Mm.
And at the top of the league table was Argentina, if I remember. And it's 3 times the level of participation than the United Kingdom.
Yeah.
Why? And what is the cultural difference there?
Mm.
I mean, family life can't be that much different. Do you have any clues as to what the reason for that difference is?
I'm not sure about Argentina. I do know about Mexico, which was also one of the high ones, because I asked a woman Mexican astronomer why there were so many in her country, and she gave me a one-word answer. Begins with M. Maids. In Mexico, there is a strata of poor women who are very, very happy to come into your house and look after your kids, do the laundry, cook the supper, clean the house, so as you can go and be a professional astronomer. I think the answer is probably different in every country in the world, to be honest, but that's one of them. I strongly suspect that in Germany and the Netherlands, the numbers are low because of the emphasis on Kinder, Kuke, Kerke. For instance, in the northern Netherlands, where there's a big radio astronomy observatory, the kids get sent home from school at lunchtime to have lunch and then go back to school. How does a woman work if that's happening?
Fascinating. I'm going to close the question session now because we've used our time, but it's a very opportune moment to introduce Professor Sheila Rowan, who is the Professor of Experimental Physics at the University of Glasgow. And Sheila, would you propose the vote of thanks? Thank you.
So, John, ladies and gentlemen, it's a pleasure to be delivering a vote of thanks to Professor Dame Jocelyn Bell Burnell for her really wonderful lecture this evening on a celebration of women in astronomy. And it was a celebration and fit in beautifully, I think, as the first lecture in this theme of extraordinary feats.
because there really were extraordinary feats that we heard about sort of this evening. The 4 examples that we heard at the beginning of women really capable of making truly extraordinary discoveries and observations about our universe against amazing odds, against huge odds. And I think there were some lessons that came across from that I felt in the talk. One was persistence, that one should never give up. These women really overcame remarkable disadvantages in their background and in the way they were treated to discover fabulous things about our universe. What the sun's made of, dark matter, which is one of the biggest questions currently that faces the physical sciences, is what is most of our universe actually made up of. So persistence really came across as an important quality. And for Caroline Herschel, I mean, I was particularly cheered up to think that I have many years ahead of me. She got her first award at 68 and was still going at 96. I think there's hope for us all there. So persistence, never give up. And there's obvious that there was outstanding talent there that really fought its way through to make these discoveries. And I think what's particularly interesting is to think what we might find out about our universe if that talent that exists didn't have to fight so hard to be able to express itself. And so we heard again about the ideas which I fully support of perhaps science moving towards women. Again, I think, how can we afford not to do that, to let the talent that's there shine through? So thanks to Jocelyn, I think, for bringing those messages this evening, and not just this evening. Thanks to Jocelyn, she really deserves thanks, and we heard some of that from the audience actually this evening about it's a long-standing commitment that she's made in both time and effort to being visible and accessible and an inspiring example, not just to women, but to anyone thinking of participating in science. And this evening is just the latest example of that. She's been telling these important stories for a long time, and it was delightful again to hear them this evening. So, Sir John, ladies and gentlemen, please join me in thanking Jocelyn for what really was a wonderful lecture this evening.
Thank you for coming this evening, ladies and gentlemen. Thank you for having a packed audience. Science, technology, engineering and mathematics. The future of the world over the next 50 years is going to need lots of that, and hopefully lots of that contribution will be made by women. Thank you.